One thing that comes up with arrays that can sometimes confuse new programmers a little bit is when we ask you to create an array that holds objects, and it turns out you've been doing this all along because in C#, strings are objects, and actually a lot of what we work with are objects. But what we want to look at here is how we can make an array that holds objects of a class that we've designed ourselves. For this video, I'm assuming that you already know what arrays are and that you have a basic understanding of what they do and how you can use them on a basic level, and you're able to write loops to do things like traversals. If you don't know all that stuff, you probably need to stop here and go watch those videos. I'm going to be using this dog class that I translated from a Java program a little bit ago, and it's probably filled with all kinds of errors, but we'll figure that out as we go along. And the idea here is that I want to create an array that will hold multiple dog objects. And so I'll clear out what's already in my template there. And I'll begin just the same way that I would create any other array like we've done so far, which is to start with the data type. Now the data type is this class that I've created, dog. And now I have to give a name to my array, which is going to be dogs. And I'll say equals new dog, and we will just have this hold about 3 dogs to start with. Notice that I have an error here where it doesn't recognize what dog is, and some of this is going to depend maybe a little bit on how you have your project set up, but my dog class is in a namespace called array of objects, and so I have to kind of point the compiler where to find that. So if I add a little room up at the top, I can add what is called a using statement. You may not have seen a lot of this yet, depending on where you are in your learning, but I'm going to put using and then the name of the namespace, which in my case is array of objects. It doesn't matter what it is specifically as long as it matches the namespace where your dog class is. And now the compiler can find that and knows how to compile that dog. Now we're ready to start creating dog objects, and I'm all about trying to save you time and come up with shortcuts to make less typing, but there's no way around it. We've got some typing to do here. There are going to be a couple different ways we can do this, and to start with, I'll just do it the old-fashioned way with assignment statements, and I'm going to treat each element in the array as its own individual object, its own individual variable. So the name of the array is dogs, index 0 equals new dog, and now I'm going to need to use whatever constructors I have available to me, and if I scroll around over here, I can see that I have just one constructor. I have to provide a name and an age for my dog. And that seems to work, so I'll go ahead and add 2 more dogs to my array so that it's full. Now, one of the things you hear me say over and over again is to just think of each element in the array as its own individual object. Don't make it complicated. So what I've got here with these 3 assignment statements is no different than what we already knew how to do from the start. So dog D1 equals new dog. We'll have Fifi. So this creates an individual dog instance or dog variable. That's the same thing I'm doing, but this time I'm putting each one into an array, but the individual elements in that are still just dog objects. All right, so let's test this out and see if we really succeeded in putting those dogs into that array. And I'll do that with a traversal, and through the magic of video editing, you won't have to watch me type this. Okay, so there's our traversal. Let's go ahead and run that and see what we get. Now remember in C#, when we print out just an object itself, we don't get necessarily what we're hoping to get. We essentially are told what the namespace and class is for that object. And so that's why it just says array of objects.dog, and array of objects is whatever that namespace is. What we really need to do in this case is print out some of the information that is contained or stored inside that dog. And so to do that, we have access to some properties here. I've created properties with get and set accessors. We could have also done getter and setter methods. It would work essentially the same way. But if we think about how we would just print out information from our regular dog object up there, D1, I would say console.writeLine D1.name, for example. And that's going to print out the name of that dog, Fifi. So to access a property from an object that's in an array, it's going to be the same thing with that dot notation, dot name, but I'm just going to tack it on to the end of my array reference with the index number. Okay, dogs I dot name, and I don't really need this line of code anymore if I can remember my keyboard shortcuts in Writer here, and let's run that. Okay, so it's traversing the array and printing out the name of each dog within the array. I'll say it again, the idea here is that the object inside of the array at this particular element is the same as any other object we could have created outside of an array. The only difference is the syntax I'm using to access it. All right, let's talk about these assignment statements we use to put dog objects into the array. They take a lot of typing, and look, unfortunately, there's just no way around it. We have to provide that information that the dog constructor needs, but we do have a couple little wrinkles here that I want to show you. So first up, I'm going to make my array a little bit bigger so I have one more element to work with. And for dogs index 3, instead of creating a new dog, I'm going to take my existing dog D1 and assign that. That assignment statement works because I am assigning an object of the correct type to an array element. So since the dogs array will store dog objects, I can put a dog object in it. I know that sounds kind of silly to say. Let's go ahead and run that and see if it gives me Fifi's name at the end of the list, and that works. So that didn't save us any time. In fact, it was actually a little more typing because I have two separate lines of code. So that doesn't help us in that sense, but it is a situation that can come up, so I like to point out that that is possible. The one you might be wondering about is the initializer list or the initialization list that we used when we were creating our basic arrays to start with. Those saved us a lot of work by not making us do separate assignment statements. We can use that same idea with arrays of objects, but again, there's only so much typing we can save. It does look a little more confusing when we use an initializer list to create an array with objects, but let me go ahead and comment out. And I'm going to define my array and then open up an initialization list. And inside of that, I can put an existing dog object like D1, okay, similar to what we did right here. But I can also add new instantiations into that array. So I can say new, I'll just copy and paste here, new dog Fido, 4, and that instantiates a new object, but instead of assigning that to an array value kind of using the index or to assigning it to an individual dog object, it's just going to put that right into the array for me. And I can do that with all of my dog objects. It's painful watching the teacher type always because you're always noticing how much faster you could do it. And I'm also running out of real estate on my screen here. There we go. Let's go ahead and run this and see if our array, was created correctly. And it looks like it is. It output Fifi first because that was the first object I put into this array, and then it went through the rest of them that I instantiated as I went. Okay, so the last thing I really want to show you to make sure it's clear is how can we use methods on objects that are inside of an array. So if I go over to my dog class and I scroll down to the bottom, I have a few different methods here, and the one I'm going to use is play outside. And so when a dog object plays outside, it gets dirty, right? The isClean property turns to false. So to call that on an individual dog object like D1, we would just say D1.playOutside. Well, again, an object inside of an array is just an object. So I'm going to say dogs, I'm going to make Fido go play outside. So that's 0, 1, index 1 dot play outside. And you can see that my IDE recognizes that that's a method in the dog class, and so it provides that as an option, right? So play outside. And so now I just need to print out the sort of the status of the dog's cleanliness status, I guess. So I'll do a couple little right line statements here for that. And in an interpolation situation like this, I can say dogs1 dot name. So this is kind of an odd looking line of code, a lot of symbols in there. But if we look at it, dogs index 1 dot name, so that's going to print out Fido, and then I just have an apostrophe S because I'm an English teacher. So Fido's cleanliness, and it's going to return the is clean property, so that's going to be true or false. And what I want to do is I want to print that before he plays and then after he plays. Let's go ahead and run that. Okay, so Fido's cleanliness was true, and then Fido played outside and we checked again, and now Fido is dirty. Now, as I was running that, I realized that I had set up this class with another method to demonstrate. So I have this isClean property with get and set access, and I'd forgotten I didn't really need to set it up that way because I had a method called checkSmell that lets us sort of take a sniff of the dog and see if he or she is clean. And so I can say checkSmell that way, and it's going to output kind of a little more of a user-friendly message. All right, so, oh, and I only called it once. I didn't call it in both locations there. All right, that's the way that I had intended. So Fido smells clean and Fido stinks. And now we've really done all the heavy lifting here. We've got the idea, and the rest just follows from that. So again, if I can treat this like any other object. So if I want to change the dog's age, I can, for example, say dogs1.age++, which is kind of a cool little line of code. That's going to go to Fido and add 1 to his age. So I can interact with these properties and these methods, and if I have getters and setters, I can use all of those just using the dot notation by referencing the array name and the index of the individual object I want to work with. And that really is all I'm going to do with objects in the context of an array like this. There is one other topic out there that I want to acknowledge. Another thing that sometimes comes up, or very often comes up, is we might define a class that has an array as one of its fields. So for example, our dog class, maybe we decide that a dog has also a handful of different kinds of treats it likes. And so we could make a field here that is an array of strings called treats. And we could, within that dog class, we could say, well, Fido likes dog bones, and he likes biscuits, and he likes chew toys. And that would just be managed within the class just like any other field. And we're not going to take the time to look at it here, but I do want to acknowledge that that's another use of arrays in this kind of a context. And so for us at this point, the big takeaway is just what I've been saying throughout the video and repeating, is that once we create an array of objects, we can work with the elements in that array as if all of those were just independent objects that we had created separately. The array is just a data structure that kind of bundles those up all in one structure so that we can work with it as a unit, and we can do things like traversals. And we'll end there so that you can go off and try making some arrays of objects.